So good evening, everyone. For those that joined earlier, I announced that we'll be starting by 8:15. That's why some people could not hear any audio. So how has our day been? And how was Sunday? Hope for those that go to church, hope we all attended church and prayed. So quick one before we start today's class. Is there anybody that maybe went through the last class, move, call? Mine was great actually. I had exam though, but we thank God. It's cool. So the move, the DB, you went through it and you have any question? I had a couple of people in my DM over the week and we had some conversation regarding the last class. And I was impressed because some questions were intriguing. I was like, okay, so if we check it from this point of view, what would happen? And it made sense that people are actually following and trying to make good use of this opportunity. So is there anyone that has any question before we start with this class? Is this Sarah Mabuchi? I I didn't see you in the last class. Hope you are good. Diamond, you're always active. Cool. Um, so let's all react if you can hear me because I'm trying to know if I'm not just talking to myself. Okay, think we're good. So that means there's no question we can. That means there's no question we can all just we can dive into today's session. Yeah, yeah, okay. That's cool. Makes sense. Let's see, let's see. Sorry, I'm trying to share. Let us just let me know if you can see my screen, please. Can we see my screen? Yes, okay. Okay. So for today's class, we would continue on uh CIA fundamentals. We'll be looking at some other instructions that are in CIA. We've made use of move in the last class. So yeah, we'll be looking at counters and timer. So during the first TIA session, I did a simple star delta program and I was talking about TON, TOF, on delay, off delay. Some people were like, okay, how does it operate? What is on delay? Why are we using on delay? Because for someone that might be hearing that statement for the first time, will be like, why not try off delay? Why are we trying to delay the on sequence? Why are we not working on the off part of the program? So we'll be diving into it today and you would see why we made use of the on delay and not the off delay the other day. So by yourself, after this session, you should be able to know what to use and when to use different timers or counters for each operation. And at the end of this session, would want to do a simple a simple PLC program, like a traffic light control kind of program. So let's get it started. So like we just used to have the normal session. If you have any question, put it in the chat. I would definitely check and then answer to your question. So so first we'll look at the pause timer, the TP. The acronym for pause timer is what? TP. So you go to your instruction search bar. If you are looking for a pause timer, you use it, you pick it, CP. The pause timer, rising edge, rising edge of in trigger the pause. So the transition from 0 to 1 would make use of this in the practical aspect. So this is just the theoretical aspect. So we say the transition of from 0 to 1 of the in is serving as the input part, like where the timer is supposed to receive a start command. So the transition of 0 to 1, so it will be receiving a pulse signal, a pulsating signal, either just one uh, on and off, like flashing of a bulb. So on and off to receive it. So once there's 0 to 1, the output becomes true exactly for the set duration. So immediately it becomes 1, like this, that we just receive a pulse from it, the output becomes true for the set duration. The PT is where you set your time, how long do you want the output to stay on. It cannot be extended mid pulse. So it's not like you can change the time mid pulse, like when the pulse signal is trying to come in. Cannot be retriggered until current pulse complete. So it's until when the time elapses before you can trigger it again. So it would not come on after the time elapse. You after is until when the time you set elapse, that's when you can now set a pulsating signal again to turn it on. Used you would need a fixed duration output regardless of the input. So you use this when we need a fixed output in situation where you want immediately this person press, like example, instead of lashing, that you want the signal that you know that, okay, once this person press this push button and remove his hand, this should stay on for so time. So you just receive the pulse. Once that signal goes in once, the output will stay on for the amount of time you set. Let's say you say 1 hour, it will stay on for 1 hour. After 1 hour, it then goes off. So it's used for alarm on, or in cases where an alarm goes on, so it's blare for the amount of time you set, like the time range you set it to. So after the time range, the alarm on goes off, and then maybe if they ignore reset for the next 10 minutes, the alarm on start again. So for valve pause, open open valve for exactly 2 seconds to dispense fixed quantity. So this is used in I don't know if we've heard of PID on control system. Mostly there are some control system where you need to regulate the dosing of, maybe you're dosing a certain constituent of chemical to the line. Okay, so once you are dosing that to it, need some you need a quick signal to transition from, okay, maybe the valve should open and close. So you don't need the valve to stay on for a long time. Let's say you have a calculation that, okay, if the valve is staying on for 2 seconds, we would have a volume of 100 or 100 volume, then we have 200 or 300 in terms of volume. So you already do your calculation, so you just use this exact time to close the valve or open the valve. Then we have on delay timer, which is the exact same one we used in the last session for the star delta connection. So when the the wrong that they call here is like the input part is true, program skip forward to the name label. So the mark destination program resumed from wrong. All wrong between jump and label are skipped, not executed in the scan. So what this is just trying to say is once there is if transition from 0 to 1 from the input side of a on delay timer, the timer stays like that. It does not respect, okay, what's happening on the other side, the output part of it. It does not respect that. It just wait until the set time has been elapsed. So after it has elapsed, then it activates the output. So it just wait, and then so once it received the signal, on signal or off signal, it just received the signal like this one, and then it stays on. After staying on for, okay, let's say you set the time to 5 seconds, It's not like the output will come on. So that's one thing with on delay. With the name imply on delay, the on will be delayed. The output will not come on immediately the signal comes in. So once the signal comes in, it take the amount of time you set it to, it delay for that amount of time. Then after that amount of time, it allows the output to come on. It's used for motor start confirmation, 5 minutes after contactor on. If motor feedback not received, then activate fail safe alarm. Alarm delay filter. Fault must persist for 30 seconds before alarm is active. Prevents nuisance alarm from transiting condition. So this is just the basic operation for a non-delay timer. So now we can look at off delay timer. So an off delay timer, the output is true immediately when the input is true. So once the in part, maybe you put a condition for a push button, a memory, an output from another part. Once you put that in, once that part is true, the output becomes true. Like in place of the on delay, that once the input part is true, the output is not true. It takes time. After the set time, that's when the output is true. But for the off delay sequence, once the input is true, the output becomes true. Then once the output, once the input becomes false, let's say the signal is cut off, it goes off, then the output will still remain true for the preset time. So let's say the time sequence you're making use of is 10 seconds, 20 seconds. After 20 seconds after the input signal is false, the output will still be true. So after that, then the output will reset to 0. So this is used cooling fan on after motor stop for 5 minutes. Conveyor belt stop delay after upstream stop for 10 minutes. So this is just to stop jamming on conveyors and all of that. You make use of this on conveyor line mostly. So let's say you have on the upstream, maybe the filler is having an issue or something, and you don't want that to cause an instant halt on your unpacker or the bottle washer or all of that. So you just use an off delay that even after the filler is having issue, it has sent signal that okay, it's not in operation, stay on for 12 seconds or 5 seconds so that there will be bottle in line waiting for it to go to the filler for filling. I think that's clear and we can move from it. So this is the example. This is our TP, the pause, the on delay, and hold on, please. The off delay timer. We made use of this on delay in our last session. This is the PT, the where you preset time, where you put the what's this thing called? The how long do you want it to stay on for? Is it 12 seconds, 5 seconds, 10 minutes, 1 hour? So you can set it to the number of time you want it to stay on for. So and the in is the condition for it to start counting the time. So you can put a normally open here or a normally closed. You tag it to a physical address or an input device. Then the for this other one, ET, that's elapsed time. It counts the amount of time that has been elapsed. Okay, let's say you set 5 seconds. It will be showing you, okay, you've used 1 second out of the 5, you've used 2 seconds out of the 5 second set, then until you get to your 5 seconds. So you can monitor how long you spent before the whole system reset or come on. So this is where we can find it here in our basic operation. Look at different. We have generate pause, generate on delay, generate off delay. So moving on, we have counter instruction. We have different counter instruction. We have count up counter, count down counter, and turn off delay counter. So these are utilized based on prerequisites and different requirements. So you make use of different timer based on what different counter, sorry, based on what you are working on. So you can use a count up timer when you want to, okay, you are setting 5 seconds and you want after a bit 5 count, then after the fifth count, the output should become true. Then count down after you set the preset time, then after the what's this thing called? After the preset time, let's say you set 5 count, then after it, once it senses one, so what a counter need is also a pulsating signal. Pulsating signal in the sense that you have a sensor wired on a conveyor line, then the sensor senses the presence of, let's say, bottle. So each time a bottle move, the sensor sends one, like in form of binary operation, like digital input 0, 1. So the sensor senses one. Once it sends one, the counter counts it as one. That means a bottle has passed. Once another bottle passes, it sends another one. Once another bottle. So each oscillation, like each time the sensor sends one and it goes off, the counter takes that signal and either count up or count down based on your own configuration. So for the count up counter, each count up rising edge, that's the the set count plus one. So each time the sensor becomes true, it add one to the set count. So it becomes, let's say you set the count of value to be 5, then for each time it will count 1, 2. Once it gets to 5, the output becomes true. Then for the countdown timer, once for the countdown timer, you already set your counter value. Let's say you set your counter value to 5 or so. Then once you start sending signal, it start like going deducting it. So it start counting, okay, 5, 4, 3, 2. It starts from 5. Instead of counting up to 5, start from 5, 4, 3, 2. Once it gets to 1 or once it gets to 0, then the output becomes true. Then for turn off delay. So this is used for maybe you want to let's say the way turn off delay, what is this thing called? Turn off delay timer works. What this does is that instead of waiting for a signal to, like, after the time, after a certain time, you should turn off that, but this will be using after a count sequence. So if you are using count up, turn up delay, so after this time on the number of count has been completed, let's say you have a sensor sending signal that, okay, this bottle have passed and you set your time count up to be 5. Then after 5 bottles have passed through the line, the turn off delay sensor, turn it off. Then count down the same method. Once your signal goes in and after 5 count or 6 counts, the what's this thing? The output becomes false. Then it's used for alarm on sound for exactly 3 seconds, no fault detection, valve pause, open valve for exactly 2 seconds to dispense fixed quantity. Used for motor start confirmation, 5 seconds turn on, sound after the contactor is on, if motor feedback not received, when the Q output, timer output is active, start fault alarm. Okay, so you said you don't understand the difference between counter and timer. For a timer, once it receives a signal in the input part, like the input part of the timer. Let me go back. This part. Hold on. Sorry about that. So this part, let's say we put a normally open here. This part, I hope you can see my cursor. This part, once you put a normally open here, once the normally open becomes normally closed, the timer does not wait for another signal. Your preset time just starts counting, just start elapsing. So let's say you set 5 minutes or 5 seconds. Once this becomes normally closed, the in receive signal normally closed, you just start counting 5, 4, 3, 2, 1. Then after the or it gets to 1, 0, then the output comes on for the on delay. So it stone does not need signal for confirmation. It just need one pulse signal, like one signal once a signal that comes once, not the one that will be coming frequently. For a counter, it need continuous signal, like okay, this signal comes once, it comes the second time, comes again. So in I'm trying to look out for a very good example where we made use of counter. I can't place one now, but maybe before the end of the session. So um for counter, it need a continuous signal. Mostly it's always connected to a sensor. So once you have your sensor, the sensor will start counting, okay, this has passed, this other one has passed. Let's even make use of a traffic light as an example. Not this type we see, the conventional one. I'm talking about the one for pedestrian. So I outside the country there are some that you can press, okay, the call button. The call button allows the driver to know that okay, someone is on the zebra crossing pedestrian road. Then after a certain time, the traffic light goes from green to red, from green to amber, from amber to red. Then once it's on red, the pedestrian can cross the road, then the drivers has to stop. So in some cases there are always timer, there are always counters there. Okay, the sensor sense that okay, this person have passed here one, another person have passed two, another person three, another person four, like that. So there are always counter that will sense that okay, this person passed here, this person passed here. Even at times you can use that counter for confirmation. It will count that okay, this person passed here one. After so seconds, the person is not there. It's not at the other end. So that this what's this thing called? The traffic light can reset. That means you should raise an alarm. Or once the person gets to the other end, is asked to press another button to confirm that okay, we've crossed successfully. Then after a so time, the time reset again, or the what's this thing called? The lights reset back to green so the drivers can pass. So I think, do you get that now? What's this person name? Yes, Sarah. Let me get it because the use state. Yeah, you cannot use counter in place of timer because counter will need continuous. Even if both of them, you have to set your preset value where you when you want it to trick. Yeah, this counts in unit and that other one counts in seconds. Yes, it's time based. The other one is not time based. It needs signal for to execute the output. Counter are using packaging. Yeah, like I said before, you use them. You can see them. It's not only package. You can see them anywhere. So yes, exactly. Not only in packaging, not only in both. You can use timer. Or it depend on your program, what you want to achieve. Where some people are using this conventional timer, there's a way you can even write your own timer. Maybe when I'm writing in when we start doing STL or SCL, I'll show you there's a way you can load time function instead of having to use this drag box and all of that. Can load the time function, put your preset value, get your output. Just you see different wonderful ways of writing program that people can make use of. Let me. So we've talked about counter. Let's look at examples. So this is count up timer, reset value. So most time a counter needs a reset because once it count up to that value, you need to press a reset so it goes back to zero and then start receiving a signal again to start counting. Then this the reset, the preset value, that's where you put maybe you want it to be a 10 count or 20 count or 30 count, whichever way. Exactly. So yeah, this is a very good example. Let's say you work in where they do biscuits. Let's look at Prime Biscuit, for example, that produce cream cracker, Biloxi, and all of that. So they want to track the amount of carton per day or thereabout. So they must have a counter operation going on. Then it counts. Oh. Then it counts, okay, how many carton is passing. Once one carton pass, it register it in the counters block. Once another carton pass, it registers. So that way they can track the production and if, efficiency of the operation. So they can't use timer in that operation because they will not be able to track, okay, how many is passing. Then this one, like this guy said also, it counts in units, and this other one counts in seconds, which is timer. Then we also have countdown, which you set your preset value, load the D. Then which other one do we have here? Let me see. There's the count. So this is it here. We have the count up down. So what this does is you can have two outputs from it. You can use it for both count up and count down. So you just set your count up sequence and what you want it. So what happens is you set your preset value. So you set it to, maybe let's say you set it to 5. Then after the 5 has elapsed, like 5 object has passed through the sensor, it has sent signal that okay, 5 has elapsed. The count up will become active. The countdown will become false. So you can get that a two-state signal. So you can make use of it that okay, once it gets to 5 units of this machine, then once it gets to 5 units, send an alarm to this. So you can just use count up down instead of having to create a count up separate, a countdown separate. So I think we're all clear with this before we move. So this is how it will be. So for the TON, these are some vocabulary is what you mostly see because so it does not seem strange. There's no priority because what happened is count up down. It's not that, how will I put it? Once it's count up, the output, it has, look at this. Let me go back. Look at this. It has two outputs. Q output for count up, Q output for count down. So what happens is once it count up, the output for count up becomes true. Once it count down, so let's say you set the preset to 5 and it's counting 1, 2, 3, 4, 5. Once that 5 gets to it, the count up becomes true, the countdown becomes false. So initially what's this thing? The default state for the countdown after you set your preset value and everything will be true until when it count down, let's say 5 have passed through it, it will become false and the count up will become true. So it's not like it needs priority or anything. So it's just like on delay and off delay. So one will stay on for so time. The countdown will stay on for the amount of time you say you should count down. Let's say you say you should count down 5, like 5, 4, 3, 2, 1, 0. So once it gets to 0, the countdown will become off. But count up, once it count up to 5, the count up will come on. So I think is that clear? Sorry. Olonode Julius. So I want to know if that's clear or you need me to elaborate, emphasize on something. So I said, okay, yeah, great. Core automation vocabularies. These are some we explain. For count up and hold on, please. I would just need a moment to. Uh, I would want us to do something for me. Please, this counter is it like a PLC module that after you are done with your programming, you have to configure it? So I want us to do something for me, please. For this counter, hold on. For this counter, let us just go through this part of it for 4 minutes. I'll be back shortly, please. Just this slide. Let's go through it and then get our questions that I want to ask. Once I'm back, then I'll start answering the questions in the chat, please. Just 4 minutes. Yeah, so I think we can continue now. Let me look at the questions I have. Someone said, sorry, please, this counter, is it like a PLC module that after you are done with your programming, you have to configure it? No, you implement it with your program. You have to add it. It's just like the way you are writing your program, you're adding the counters. They are part of your program. They are, they are even integral part of your program. So it's just, how will I put it? There are things you need to make your program work. It's not a module similar to timer, just like, yeah, exactly. Yeah, between timer and timer, I didn't hear what you didn't. Okay. So difference between timer and counter. I said, even someone have said it in the chat. For timer, it makes use of preset value and it counts in seconds. Once it receives a signal once, it start counting down or counting or sorry, it start counting the time, preset time, it start exhausting the preset time. Then you start hearing things like, okay, your time is going down like 5, 4, 3, 2, 1 in terms of seconds. But for the counter one, when once it receives a signal once, it's either count up or it count down. So depending on the type of counter you are using and on what you configure it to do. So if you are setting your percent count to 5 count, then what you need is it needs that signal, the input signal to come 5 times, on and off 5 good times. So once it comes on and off one, it grabs that signal and say, okay, it has count one. Once you go on and off two, it counts it as two. So compared to the timer sequence, the timer just need either one short signal or one short off signal. So either ways, but they are not the same thing and they don't do the same thing. Please, sir, can you explain turn 2F? I tried using it and I noticed it has to move from 1 to 0 and then one of it, one for it to work. It doesn't just work immediately. But so for an off delay timer, what happens is An off delay timer compared to on delay that once it receives signal, it starts counting. Off delay timer starts counting because the way with the name imply off delay. Off delay means it should go off after the input signal has stopped coming. So after the input signal stop coming, which means the input has to go from 1 to 0. So once the input goes from 1 to 0, it starts counting. After that time sequence, then the output goes off. So for what you did now, that's for the your Deji. So that's the exact way it has to work. Compared to on delay comes on immediately. You send signal, it starts counting up. Is that counting? Why am I making use of count now? So on delay, once you send the input signal, the time start elapsing. Let's say you put 5 seconds, you start counting 5, 4, I be 1, 2, 3, 4, 5. Once it reaches 5, the on delay, the output comes on. Even with the name, just look at it. On delay, it takes time before it comes on. Off delay, it takes time before it goes off. The only difference is for off delay, it needs you to turn off the signal from the input side because for something to take time before it goes off, the signal has to stop coming. For it to be an off delay, it has to retain signal. So it has to make the whatever you are controlling stay on even after the input signal has gone off. So that's just the basic difference. Let me look at. Okay, I think someone has answered it. Some generators. Yeah, exactly. Then counter continuing. Yeah, everything is correct. The person that said counter per pulse, even per unit. So pulse, like okay, each time it comes on, you count one. Each time it comes on, you count two. So either ways, we are all active and correct. And I like the way the direction at which we are going. So can a counter be used as someone even put thumbs up? A counter cannot be used as a timer at times because don't worry, instead of trying to argue or trying to explain for that we'll do a simple example. Let's just stay tuned. We'll do a simple example. We'll make use of a counter and we'll make use of a timer. So you see the difference instead of trying to speak big English. Can a counter be used as a time? So I think that's all the question we have. We've checked this. So we are looking at the core automation vocabularies. These are symbols, terminologies, what you would encounter when you're writing some programs. You can see stuff like TON and you'll be like, how do we get here? What is TON? So you can also see stuff like TOF, off delay, then TP, timer pause, PT. So these are the parameters you have to set. PT, the preset time, the elapsed time. I showed you where the elapsed time is. Let me show you again. So look at it. This is PT, reset time, and ET as elapsed time. So this shows you how much time you've consumed out of your preset time. Let's say you set 10 seconds, it will be showing you like, okay, you are in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it will be showing you how much time you've used. So let's go back to this. Then we have elapsed time, count up timer, countdown timer. We have count up, count down. I showed you that. So for the count up, like the elapsed time, compared to the last time, we have current value for counter. Current value show you the amount of time it has count. Like, okay, we already have 4. We've accumulated 4 counts, like 4 pulse. Like that engineer said, we've had 4 pulse. Then preset value. This is the count value you want. Okay, we want you to count up to 5 pulse or up to 10 pulse. Then let's see what else? Rising edge. So signal transition from 1 to 0 require, yes. So falling edge from 1 to 0, one shot signal can be used. So thank you very much. Let's do our normal going to TIA portal and make use of counters so we can all be sure we're on the same page. So someone asked a beautiful question in my DM the other day. I don't know, I can't remember the person's name. but the person's question made a whole lot of sense. So, person was like, he or she was going through the YouTube live and noticed we change. I hope you cannot see the TIA portal page now. Please let's confirm you can see the TIA portal page before I proceed. Can we see the TIA portal page, please? I would like us to. You can't see TIA portal. I think I'm sharing that already. Is there any other person that can't see the TIA portal page? Let me know in this. You can see it somewhere. Is it yes that you can see it or no that you can't see it? Okay, I can. Yeah, yeah. I think we're good. Engineer Benga, I think you might want to check your network. You can see it. Okay. So what the person asked was, sir, why do we change from um input? I don't know. I think I replied in the person. I think I did. He said, why do we change from input to a memory when we wanted to simulate? So I think I would say there are different type of simulation. You can, no, counter is not an encoder. An encoder is an analog device. A counter is not an analog device. If a counter is not an encoder, please. So the best way, why do we change from an input device, an input signal like I0.0, an input address to a memory bit when I wanted to simulate? So I told the person that, okay, why I did that, because some people might also have gone through the video and you have that question that why did I change it? If you want to simulate, you have different method of achieving that. You can use a force table. Whereas, let me let me just do something. Let me do an example so we see what I'm saying. Here is a force table. We have wash and force table here. Look at under force and wash table. You open. Sorry, please. I just want to clarify that so people don't seem confused. I hope we all, by this time and hour, we all know how to set up our PLC sim. Like, okay, you want to start simulating your program. If there's anyone that can't do that, please let me know in the chat box. If you cannot still set up your simulation at this hour. So let's go online. I've not called it in my OB1. We definitely let you know. Hmm. Yes, definitely. It's not because the TI Portal can work without network. You don't need data to use TI Portal. Why will you use? Why is this guy not monitoring this? So look at something. From here now, I did not change it to memory. I did what? Force it. Force bit. Then it became one, and then the start push button. Let me remove this so you can see it. Then the start, it's simulating like the start push button has been pressed. Let me remove the first now, turn it to 0. It goes off. But if you want to make use of modify, look at, you say modify. This way, you don't need to create force table. It's another way of simulating signal, like, yeah, simulating signals. If you don't want to create force table, you can just come here and modify to 1. You see, it will not work because it's a physical address. But if you are using a force table, it will work. So the reason why I changed it from a physical input address to a memory was because we're not making use of a force table. So, do anybody have any question on this? So please, if you have any question on this, let me just see it in the chat. If not, let me know so we can continue. So, exactly. So I think we're back now. There was no question. So it was a network issue. Yeah, thank you very much. So I think we understand this now. For the person that has the question about why I made use of a memory instead of this physical address, I think you get it. So what I wanted to do was to be able to modify instead of having to create a first table. So I can also do the memory part here. Let's say M3.3, compile and download. How do I undo multiple input that need to run simultaneously? Mission for a small project. Exactly, you can create a first table. Then, or yes, a first table, then you put all of them inside. You see the way I drag that and drop it there. We put all of them inside, modify, and then turn it on. So look at this now. Instead of having to go and force signal to it, I can come to monitor, under monitor, modify to 1. Then after modifying to 1, look at it has become 1 here. It's active already. Modify to 0 instead of having to go through the stress of creating first table and all of that. So I think we're good on this. So now let's look at an example on how to use your counter, timer, and yeah, maybe count up and count down. Count down, sorry. So I think I have something here already. So this is an off delay timer. So for that person that made use of off delay timer that had an experience with it. So let me just display what an off delay timer does for you. So for this, let's for the start, let's force value to the start now. Let's force 1, yes. Look at it. The output is already true. Then I brought the output down here. Look at this now. The valve fill valve. The fill valve is already active. That means let's say the filling has started. Let's now go back and force this back to 0. So that means the start push button has stopped. Look at this. The fill valve will still remain on, will still remain open for 4 seconds before it goes off. Let me increase the time so maybe we can see it. 10 seconds. No, let me use 10. Let me use 7 seconds. So let's now come up here again. Download. Force it to 1. Then let's force it to 0. So look at this. The output is still staying on even after the input signal has been cut off. You stay on for 7 seconds, then it goes off. So now let's make use of an on delay. Just want to show us what these guys do. Instruction, timer, on delay. Okay. So let's put the same 7 seconds. Let me remove this. So open our first table. So just fix your eyes on the fill valve. Let's force this input to 1 now. It's because of that person I make use of first table this night. Oh. So, oh, sorry. I stopped monitoring before. Hold on, please. Let me download this. Then go online. Let's open our first table. Let's force it to 0 first. Yes. So notice what happened now. For off delay, sorry, the other time, once the input signal goes off, the output still remain on. But for on delay, once the input signal goes off, the output goes off immediately. So let's turn on the input signal now. See, the output does not come on until after 7 seconds. So even before the 7 seconds, okay, look at it now. The output comes on after 7 seconds as elapsed. So you can now force this back to 0. Yes. Then the output goes off. So I think we are cool on delay and off delay now. Please let me confirm that. Let's know if we're okay with on delay and off delay in the chat. Or if anybody still have any question regarding on and off delay. Yes, Sarah. Diamond. I don't know why it's always the two of you I'm always calling. Adeboye. I think we're good. Yeah. Yeah, I think we're good. Okay. Okay, sir. Yeah, let's move on. So let's go to the counter sequence. Let's make use of count up and count down. Then let's do something. So we've seen how this operates now. Let's now go to counter. I think we can delete this and bring in a counter instruction. I think instead of even going through that, you can just bring an empty box from here. Change the name to counter. Maybe we can do that. Nope. Let me just drag it. So you come to your instruction bar. From your instruction, you can see we have timer, we have counter down here. Then this count up timer, counter, sorry. So let's put our preset value to be 6. Then this one will be showing the count value. You can address this to an output. If you want to be showing, in places that you want to be showing, okay, how many stuff have been counted, you can tag this to an integer output and be displaying it on an HMI. So you can display it on an HMI, we'll be showing them, okay, how many people have passed, how many carton have been packed, and all of that. So let's download. Okay. So look at this. This is the count value now. It's in 0. The preset value 6. Count up timer. It has not received signal. That's why everything is still 0. Let's change the signal to 1. Look at the output will not come on. But the counter has showed that it has what count 1 already. Let's now do it until we get 6. So what we need now is for the output to go off. I should have just used 3. Well, don't worry. For it to now come on again. 2. It needs to get to 7. Go off. Come on again. 3. Go off. So this is not like industrial practice. You can be industrial practice. you can make use of a sensor for this counting sequence. So a sensor might be the one sensing maybe a carton passing, um, bottle passing. So it should just be counting it, how many bottles have passed. So we already have 4. Let's do 5. 5. There's another one first. 2, 6. Look at on the sixth count, the output became true. So let me now do something. Let's take it to 7. You see it. Okay, no, it's already true. Let's take it to 7 and see what would happen. Let's take it to 7. So since the output is already true, it will remain true even after you change it to, even after it gets to 10, 100, 1000, you just continue to count up that way. But once it has gotten to your preset value, the output becomes true. So what can you do now? Even when the output goes off, look at the input goes off, sorry, the output will still remain on. So how do you turn this counter off? You have to put a reset. So let's put a reset here. Let's now call it M2.2. Download. Load. So look at what happened now. It's already on. The output is on. Let's now modify this to 1. The output goes off. Please let me know if everybody is clear on this also. You get the way I did that, the output and the input part. Yes, yes, definitely. Let's make use of a physical address. Let me see, stop. I already have my start and stop. Let's make use of stop. So look at this now. As it stopped, I can bring it to my first table. I need to download back. Yep. So now, no. Let me just change this to 3. So we don't have to start doing the 1 to 6 again. So let's count. 1 comes on. Okay. Yeah, 1. Then let's force it to 0 back. So on the second count, the output comes on. Because I changed the preset value to 2. 0. So now the reset, since it's a physical address, you can force it from here first. Let's force it to 1. Yeah. It will reset it. So it can also be a physical address or a memory, whichever one. So I think we're good now. Let me know if we're good on count up timer. So let's make use of countdown. I'm not hearing anything, no. I don't know. Maybe. Anita, if you are with us, let's know if you are good. Ayodeji, Nicholas. Are you also good with the count up? So, okay. I think Nicholas is active. So let's use countdown now. Let's make use of countdown. Go to instructions, count down, delete, delete. Reset value, let's make it 3. And I don't know, let me see if I can. A quick way to also know, let's say you are using a block for the first time, you've not encountered a block before, maybe counter, move block, anyone, and you don't know, okay, what parameter can I put in the LV, CD, PV port? You can use F1. Just click on the block now and press F1 on your system. Why is it not showing? Let me see. Am I the one not seeing it, or is the one that is not showing? Okay, still loading. Hold on, please. It's supposed to. uh So it will give you information about that block you brought out. Look at this countdown block. This counter instruction. So it will explain everything you need to know about it. Then about the port that is available, the LD port declaration, you can put an input bit there, in memory, anyone. Look at it, bool, PV. You can set an integer there, output constant, memory area. So you can read about it. They can even show you an example of how they use it. You see? So this can help you in cases of new blocks you are not used to. So I'm just trying to show us. So it's not every time that maybe you are seeing a block for the first time, you don't know why they use it in that program. You just click on F1 on your computers. For some people, so some people's laptop, you might need to press FN F1, FN then F1 on your laptop before it works. But some people you just use F1. So I think we're good with this. So let's make use of the countdown. We set the out to 3 and then let's now download. What do you notice there now? The output is already true even before the counting operation starts. So what happens for countdown is once it now counts up to 3, it resets the output. So let's do that. Let's force it to 1. 1 minus 1. So it's minus 1 from that 3. That's 2 like that. Sorry. Force to 0. Minus 2. Then hold on. I think I made a mistake somewhere. Supposed to reset. Mm, Download. Let's go right again. Let me modify this to okay. 0, 1, false to 0, then I don't know if we saw what happened just now. So, for, I think someone is saying something in the chat or something. Okay, let me just demonstrate it again. So we can now get the same way a count up time counter has a reset. This countdown timer also has a reset. So what this countdown timer this? What am I saying? What this countdown time counter does is once you energize this, look at this. Let me change. Is there a way I can change this here? Okay. Let me change this to 4. Download. Look at what is happening here now. What do we have up here? We have 3 instead of 4 because our time is supposed to start from 4. So for you to allow it to start, you have to load the PV value. So let's modify this to 1. Look at it becomes 4. Then after loading the PV value, you will now start toggling this 1. It becomes 1 minus first. Hold on, please. Just have to force it. That's why I used to prefer modify to force. Because you always have to look at it will now start counting down from 4. So initially you need to activate it. Let's say you set your value to 10. You have to activate the 10. You click on it. Okay. You can put this to a physical push button or a memory or something just to trigger it. Then once you put it in, it activates that okay, it's 4 we're counting down from. Then you start toggling this, the on and off, or the pulsating signal. Turn this off. Turn it off on again. So we need 2 more. One more. And the output comes on. So once your output is active, you can also now come here, modify to 1, and your output goes off. And then it load the 4 again. So it need another 4 signal from this for your output to come on. So do we have any question on this? I want us to carry out an exercise before we end this night section. Please, if you have any question, let me get in the chat. Yes, diamond. Yes, yes, yes. It can be just sensor sensing object. Yes. This on and off is because we are doing what's this in simulation. That's why we have to physically try to turn it off and on. Then someone also says so the LD basically resets input. Yeah. So you set the output, not the input, and then load the PV value to it, the set point value, the counter set point to it. I think there's no other question in that regard. So let me let me just read out what we are. Okay, there's no other question. Let me read out what we are working on. So let us please can you all see my screen? The one of a scenario, you are programming a pedestrian traffic. I would like us to use the chat box so I will know if the thumbs up is for yes or is for no. Okay, I think you can see it. So, okay. You are programming a pedestrian crossway, a crossing traffic light. Well, Yeah, sorry everyone. I had a bit of a network issue. Please let us all agree that, like, let us all send an emoji or something to signify that you can hear me. I don't know what's wrong with Fiber One this night. I don't know. Okay, thank you. Sorry. So I think let me share my screen. So this was where we stopped. We're talking about the count up and count down. They want to take a simple task, the one on the on the pedestrian crossing traffic lights. So the operation is when a pedestrian press the call button, the light sequence green, amber, red, pedestrian walk through when it's on red. After the red phase, the system automatically returns to green. A cyclic counter tracks how many crossing cycle have occurred for maintenance log. So notice from this now, we have to identify all our input signal and output signal. So our input signal, we'll need, instead of start push button, we'll need a call push button from the pedestrian. I think we can all see me. So go to my PLC track. So instead of the start, we'll make it call push button from the pedestrian. We need a sensor. Okay. Let's use the call push button from the pedestrian. So once the pedestrian press the push button, we start counting. Abi, yeah, the light goes from green, this and that. So let's make output for our red. Let me replace this with an output. Green, yellow. This is also an output. So I know what's going on. Oh, let me go to my main F here. So once the person press call, it activates a memory. So okay, so let's make it a memory. So activate a memory M0.0. Then we use the memory to trigger our timer sequence. So from the question, it says when the pedestrian press the call button, light sequence, green, amber, red. So the green is the default light. It stays on for 30 seconds. After that, the amber comes on for 5 seconds. Then the red comes on for 20 seconds. So at that 20 seconds count, the pedestrian is expected to cross the road. So this is what we do. So please, I would like someone to tell me in the chat which kind of counter do we use. Note, the question said it should stay on for 20 seconds after the pedestrian have pressed the call push button. So please, which kind of timer should we make use of? So it's not like I'm the one writing the program. We are writing it together, or you are even writing it, not me. I'm waiting on Michael Sama have said his own. Let me hear from someone else so we'll know. Okay. Okay. Uh-uh. When do we do GOT? Adebayo. Adebayo Adeyinka GOT. Wow. Hey, first time I'm hearing GOT timer. So I'm making use of another delay timer, which is very correct. Because note, the question say after the signal has been pressed, that means it should stay on for 30 seconds after it has been pressed. So we bring enough delay, insert it here. Okay. Delete this engineer. So what happens? Delete. I was just joking. So this is red. Red. And output to red. Reset value 30 seconds. We'll be able to wait for the 30 seconds. Let me just use 20 seconds because we start waiting for 30 seconds now and be checking the time. So what happened there is once the person press the call, this memory M0.0 is active. Then M0.0 comes here. Then activate this. Then let's say, okay, no, sorry, not the red, it's the green. Green should come on first. Then for the next light, they said once the green is on for 30 seconds, after the green goes off, the yellow amber should come on for 5 seconds. So how do we do that? Let me in the chat so it does not look like I'm the one typing everything. So what the operation says is after the green goes off after 20 seconds, the yellow should come on for 5 seconds. Not stay on, no. Come on for 5 seconds. So how do we do that, please? I'm not saying nobody's talking, no. He said after the green goes off, the yellow should come on. Okay, Michael Sama has a point. Said the green signal. Okay, I'll be doing it the way I'm saying it. The green signal. Okay, let's bring the green here. Change this to normally open. Change this to normally open. Then remove this. The green signal triggers the yellow. Okay. We use on delay. Okay. Okay. So once the green goes off, that's what the operation said. Once the green goes off, the the red, the yellow should come on for how many seconds? Should come on for what's this thing called? For 5 seconds. So once the green goes off, the yellow should come on for 5 seconds. So I'm still trying to get people's opinion before I do it now. When signal turns on. I'm not making use of count up timer, sorry. Count up, counter, sorry. Someone said the green signal should turn on the amber TON. Hmm. Remember, if you are using on delay timer, on delay timer, once the input signal goes off, the timer will not work. So, and this one says after that one goes off, that the timer should work. I'm expecting someone to say something that we did in our last class. Is it last class? Yes, I think. Made use of something, and nobody's remembering the thing. If we are using normally close contact of the green, so put normally close here. So what happens is whenever the green is on, this will not come on. So when the green goes off, the on delay timer start counting. Then if the on delay timer is counting, remember for the on delay, the output does not come on until after the time elapsed. But for this condition, we need the output to be on until after, yes, we need the output to be on until after a certain time. That's when it should go off. There are different methods to writing this, not latching. If you use normally close contact and on off delay, if you put normally close here now, we add an off delay timer to it. Remember, for an off delay timer, the operation only goes off, the light only goes off after the what is this thing called? The light will stay on immediately it receives signal. Then it goes off only when it stops receiving. No, the timer start counting when it stops receiving signal. So when we're using normally close. So once the green goes off, it starts receiving signal and there's no way to cut off the signal. So the off delay will not work. Just waiting for one more person, then we'll go ahead and solve it. So let's just do it. Let me just do it. Someone said something. So like I said before, when we first started this class, I said for programming, there are different methods to achieving the same output. The way you might write it now, another person will write it and will be like, wow. So this same method, we can still achieve this. So for me, what the question said is after 20 seconds, so the green will stay on off delay. After 20 seconds, the green goes off. Now, we want it that after the green goes off, the red should come on. I mean, the yellow should come off for 20 seconds also. So how do we do it? Once the green goes off, using we've not studied. I want us to use anything we've taught. I don't want us to use negative edge. I know you are a senior man, Victor, so I don't want us to use negative edge signal. Do we do negative edge? Sorry, do we do negative edge? I don't think we've touched negative edge. That's why I don't want to bring that up. No, we didn't do negative edge. Set, reset. That was what I was waiting for. Set, reset. So there's a way we can make use of set, reset here to just achieve what we need. So let me just do something. M1.2. I just want to do change this to set. Bring out another output here. I was waiting for someone to say set reset since. Just look at what I'm about to do. Please, can we still see my screen? I don't know. I think this network is just messing with me. No, no, no. Okay. Okay, I think you can still see the screen. So what would happen here is once this off delay timer starts counting, it comes here set, then the green light comes on. Then after 20 seconds of counting, I don't know if anybody, if you can hear me, please just thumbs up or something. Okay. Okay. I think we're good. No, we cannot use 1.2 two times. And some people have a lot of questions now. So what I did here is once the call button has been pressed, the green comes on. Once the green comes on, after 20 seconds, this still remains set. This goes off. So what do? We need the red to come on. So we bring it here, normally open. You say M1.2. Then you bring, I just want to make sure that we're using everything that we've talked about. Bring an off delay. Put it down here. Okay. Bring this here. Put, let's say after 5 seconds, then the output should be red. The other shorter condition we can use, but I want to make sure we're using the on delay, off delay, set, reset, and all of that. So what happened now is once once this goes off, so once this goes off, the red comes on. Yep, 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 yep. So bring a root here, put another delay timer. Okay. Hold on, please. Sorry. Trying to look at the way we can just utilize all of these blocks. So we bring in this signal from our set, put it down here. So I'll explain what I just did in a moment. No, I was not saying anything before. So what I did is, once the call button has been pressed, the off delay timer after 20 seconds. Wow. So the after 20 seconds, once the call button has been pressed by the pedestrian, then after 20 seconds, the green light goes off, then the red light comes on after 20 seconds. So what I want to do now is I want the red light to go off after 5 seconds. This is milliseconds, not seconds. So we'll simulate it and see the operation. On delay. Yeah, I'm not saying anything. I'm just, what's this thing called? I'm just putting in the signals and beats so you can just see it. So I'll explain it once I'm done. Once we start simulating. I was not saying anything before. I just want to make sure I isn't both timer and this thing. So let's try this first. Compile, download. Where's the red? Okay, this is the red light. The force for the call, let me change it to 0. So I don't think we saw what happened. Let me try it. Let me increase this time to 25. 25 seconds. What's table? Then split the screen. So let's force the call to 1 now. 1 then. So now the green light is on for 20 seconds. While the green is on, I'm not expecting the red to be on. The red is not on. 96 something, yeah. Okay. Okay, I know why. So the call button modified to 1. Let's see. Someone said, can I please? No, the code has not been set to be sent soon. It's very fast during the first action. So I was unable to catch up. Yeah, okay, let's do it. Let me do the first again. So bring your first table, first call to 1, and force it back to 0 so that the timer can start counting. So now the green is on, and then it's on for 25 seconds. Let's just see it on for 25 seconds. While the green is on, the red is not on. The green is still on. The green is off now. Trying to see why this guy is going off immediately. Oh, I think I get why it's going off. Let's change this to off delay. Now let's download. So after this, I would generate the attendance code so we can share because it's late already. First table, split your screen. Let's force the call to 1. Force the call to 0. So the green is on now. And the time is counting for 25 seconds. I don't know why this red is not coming on. Hold on. Trying to get why the red is not coming on. I don't want to use any other command except this timers. If not, we would have just done it to its negation and all of that. Attendance code has not been sent to this engineer asking for attendance code. It will be sent after once we do the green and red, I'll send the attendance code. I just want us to see how it would operate. So this comes on, then after 25, once this goes off, I want this to come on for. Okay, I think instead of that, yeah, I'll drop it also. I'll drop it so you can practice it here. Yeah, I've removed the M1.2, so I'm coming. I want to just get something straight here. I would not want to make use of another command. So the off delay, once this guy goes off after this. I think I get what's going on now. Now. So the green is off. The green goes off normally. So it's how to turn this red on that we're looking at. Coming. The normally open here. Where is this guy? Mhm. Put this to a memory. Then for instructions. Say should stay on for how many seconds? No, this will work. Positive and negative edge would work seamlessly, but I want us to make use of this. Let me put it says you stay on for 5 seconds. After 5 seconds. and the 3. It will come, it will work now. Sorry. So after 20 seconds. Yep. So this will be the red now. Ooh, finally. So let's check. So let's force B to the let's change back to 0. Close this pattern. Then the green is on. Our red is not on. The green is still on. Our red is not. Now our red is on. Hold on. Okay, 25 seconds, yes. Now our red is on. The green is off. This 5 seconds is too short. Let me make it longer so you can see the operation. Let me make it like 20 also. So let's just look at this, sorry, for the last time, and then we can call it a night. I've not added the timer. Maybe in the next session we'll add timer and all of that for this before we start our class. Let me split this into two. First, the call part. Yes. Then force it back to 0. Okay, close this. And this, okay. The green is on now. Then the green is staying off for 25 seconds. So let's look at the red. The red is not on. So let's let the green go off first. The red is not on yet also. So our green is off now. Our red is supposed to be on now. M1.2. Hold on, please. Sorry, M10.2. Just want to make sure we were able to do this tonight, so we don't move it to the next class. M10.3. Yeah, 10.3 is here. This is 5. Let's say 10 seconds. After 10.2 comes on. 10.2, 10. So for this, let's force it. Let's force a value to it now. Split our first table. One. 0. Boy, oh boy. It's bugging me. So look at this. The green is on. Trying to see why this is. Okay, this is coming on immediately. Um, Hold on. I'm confusing myself. Yeah. M10.4. I did not reset the set part, so the set is still saying set. So that timer is just counting. Where is it here? This timer is not operating. That's what I'm looking at. That was going on. M1.2 reset. M1.2. So it's still assuming that it's on for the simulation. So let's download now. So now I've reset that. So now let's do it now. I think this is the last time we'll be having to do all of this. So please just look at this now. I will also share their question on the group. So let's force it back to 0. So look at this. So the green is on. The red is not on. The red is not on. The green is on. Now the red is off after 5 seconds. Let me increase the time so we can see. After 10 seconds, so the red went off. The red went off too fast. That's why we didn't see it. This is the red here. It came on. Let's reset this. Modify to 1. Modify back to 0. Download. The code has not been shared. After we finish this now, I'll share the code for everyone. So let's modify. Let's just use the first table for the last time. So let's force this to 1. Yes. Force it back to 0. Like, I always have to attend that we've not been able to do. So the green is still on. The timer is counting then. Let the timer elapse first and let's see what will happen. I can also share this program with anyone on the group if you don't mind. So the green is off now. Let's see. Exactly. The red is on. So the red is off already because of the time has elapsed. Let me increase the time to 15. So you'll see it. 15. Yeah, you see it. Oh, sorry about that. So this will be the last thing we'll be taking. Let's just modify this. I just want us to see it work. First to one. Yes, then first to zero back. To simulate the call push button. And now let's stop splitting the screen. So our green is on, our red is off. So after 25 seconds, sorry, just see this. Once this operates, then I'll share the code. 25 seconds, the green is off. The red is on now. So the timer for the red is counting also. So after the time has elapsed, see the red is still on and the green is off already. So once the timer for the red elapses, the red goes off. So we can add the command for the yellow and then add the counting sequence. Just to save our time, maybe when we are doing the attendance, I can be doing that for the yellow, so we'll see it all. Let me try and generate the code for the attendance. Because some people are already, before we have people that will vex here. Okay, I want to make sure I'm not sharing the whole screen. Hold on, please. I want to generate the code, so. Oh, I'll share the attendance code now. The stuff is already operational, it's already working. I just wanted to explain how the code work and why we had that issue. Maybe next class I'll show you how we could just have used this thing that this person was talking about. Um, the negative and positive edge. Maybe next class I'll show us how we could have used that. Because the negative and positive edge will just have made it sweeter and very, very easy. So I'll be sharing the code now. Please let us all just signify we can see the code. Just react. Let me go and help our people on YouTube also. You can't see it. I just posted, okay, it was under someone's comment. I've drop it again. I just did that. Boy, oh boy. Tomorrow is Monday. Sorry. Um, so I'll drop the attendance code on YouTube now. If you are on YouTube, you should be able to see the attendance code now. Network. Yeah, sure. I'll do that tonight. I'll share the screenshot. I would have loved us to add the yellow and all of that, but I think it is what it is. I'm also going to be at work tomorrow. Tuesday, care. Let me check it, please. Some people might not even notice. Tuesday. Hold on now. Okay, okay. Saturday. That's lecture 12. Yes, yes, yes. Don't worry, we'll change. I'll remove it from. I'll drop the code again. Yeah. Thank you for noticing that because some people might not even. Yeah. So this is the updated code now. Z. Yeah, yeah. I had to close that code. It was reflecting for Tuesday instead of Saturday's class. So we can use this updated code. The counter does the number which was like set. Yes, definitely. Yes. Yes, yes. It counts up to 100. Just name it. Yes, the code is not working again. This is the new code for people on YouTube also. If you have used the old code before, please make sure you are using the new code now because we'll delete the attendance for the old code. That mistake that was made. Okay. So the person that Bright, I think I've answered your question that way. That's the code. Oh. So please, do we have any question again? I know this traffic light on is it seems cumbersome and confusing somehow. Is there a way you can recycle the code? I don't get your word. What do you mean by recycle? Oh? No, 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 no. You have to use the new one I just sent. It's a one-time code, not user base. Okay, the program. Yes, yes, yes. Like I should do it again so you see the operation, right? Okay, not what you're talking about attendance code. So for the last time, for the person that just requested for it, let's modify this to Mr. Kenneth. This your situation is peculiar. So for the let's simulate the press button. So the press goes from 0 to 1. That means someone has pressed it already. Then 0. On its own, over and over again. Yes, yes, like repetition. I get that, but yes, we will do a typical street light self on Tuesday. I think we should do something like that. Why this now? Because you look at the question we're working with. It stated that it is when it is pressed. It does not say like typical street light. What this does is it tells the driver to stop. That okay, someone want to pass. That okay, someone want to pass the road or stop so that the person can pass. That's what this one does. Not that like the normal conventional street light that we have around that will just red, yellow, and green. for normal. We can do something like that too. So what that one will just be that once it gets to red, it will start again. You can do that here. You can do that. Let me see. Is there any question on YouTube? So after the attendance, maybe we can call it a night, and then on Tuesday we come with fresh energy and any other new question we have. Sorry about the delay. It's late already, and even myself. Traffic lights. I didn't get this question right. You said traffic light programming, real help in real life industrial. Abi, what's this? I didn't get the question, please. If we can rephrase or something. Please, if we're all done with the attendance, let me know so that I can end the live. So please, can you share the program through the WhatsApp group? Yeah, I'll share the question on WhatsApp group and can also try it out. I'll share the program on WhatsApp group. Is it this one I wrote or the question itself? Tijani? Okay, okay, okay. I think I get. So I think there's no any other question from anyone again. So all that being said and done, I think we can call it a beautiful night because myself also I'm going to work tomorrow and I have to prepare. Thank you all for your time and I hope and pray to see everybody in the next class. I just want to make sure I've answered everybody's question before going off. I think we have some questions. Oh, the green light is not good enough. I'll share the program. I'll share the program. I'll share the program. I'll leave the live now.